Hello, hello. We're moving on in Chapter 4. So, Math 8A students, we're now tackling Section 10.4 on radical equations. And the first thing I want to do today is start with a sailboat problem. So, apparently, the speed of a sailboat has to do with what's called the waterline length. The waterline length. Okay? And you can make a formula that relates hull speed and waterline length. And that's the formula right there. So, hey, next time you're wanting to know about hull speed and waterline length, just remember this formula. I want you to use that formula to solve the following problem. Idris and Sebastian are sailing in a friend's sailboat. They measure the hull speed at 9 nautical miles per hour. Find the length of the sailboat's waterline. Round to the nearest foot. Would you please just pause this video, take a few minutes, and see if you can solve this problem. Okay, now that we're unpaused, we're basically just going to take this formula and we're going to plug in what we do know. They measure the hull speed at 9, so that was the h. So I'm going to put a 9 there, and then 9 equals 1.34 times the square root of that waterline length. And that's the only variable that's left, so I should be able to solve for this. And I don't think solving for this will be super difficult. What am I going to do to solve for that? I think I'm going to divide by 1.34, right? So I get my calculator out, and I do 9 divided by 1.34, and I get about 6.7-ish. So I'll say about 6.7 is the square root of L, the square root of the waterline length. So what would I need to do to find L itself? Well, if the unsquare of this is that, then wouldn't I have to square both sides, basically, to find what my answer is? And it'll be an approximation because of that approximation there. And luckily, I left that number up on my calculator, and all I have to do to square that is just hit the x squared button, and I can tell that the whole length of this sailboat is approximately 45 feet. All right, so that's a long sailboat. But the reason I bring this problem up is we're going to be solving problems that have a radical in it. And we're going to solve those equations, and we're basically going to follow a very similar format to what we just did here. So our first example problem of the day today is we're going to try to solve this equation. The square root of g minus 6 equals 3. Now, what I want to do is I want to give you kind of a step-by-step problem solving method for solving what we're going to call radical equations. Why are we calling these radical equations? They're equations that have radicals in them, and we still need to solve for g. So what's our first step? Well, our first step is we're going to try to get this by itself by adding 6 to both sides. That will give us just the square root of g equals 9. What do you call that when you get that thing by itself? We call that isolating. We're not really isolating the radical or the variable, because the variable is still inside the radical, but we are isolating the radical. Step 1 is to isolate the radical. Then, what did we do on that sailboat problem to get g? Well, we basically squared both sides, right? So what's step 2 when you're solving radical equations? Squaring both sides of the equation. And then sometimes you're done and you have your solution. Other times you've got to still do a little bit more solving. And then anytime you're solving equations, what's the last step? Always, always, always check your solution. And I'm going to put parentheses S because this possibly might end up giving us more than one solution. All right, this example was fairly simple and easy. We didn't check it, but I could check it. If I put an 81 right here, what's the square root of 81? 9. What's 9 minus 6? 3. Check. Now I can put a box around that answer with confidence because I know for a fact that G equals 81. Okay, let's see if we can take this same method and apply it to more problems. Let's say I'm trying to solve this. The square root of D over 3 is 4. Okay, step 1 is isolate the radical. So how do I isolate the square root of D? In this case, I do the opposite of dividing by 3, which is going to be multiplying by 3, or kind of like multiplying by 3 over 1, so that the 3's cancel and I just have the square root of D equals 12. And again, on this one, I'm going to square both sides next, and you can write the parentheses and the square signs, but on a problem like this, you kind of know that squaring a square root gives you just D, and we pretty much did step 3. We solved it. Now we're just going to check our solution. So if I were to put a 144 right here, what's the square root of 144? 12. And what's 12 divided by 3? 4. So again, we are totally confident that D equals 144, and that is our solution. So let's keep on trying some more problems. Let's try to solve D equals the square root of 12 minus D. Okay, step 1 is isolate the radical. The radical is already isolated on this one, so we're good to go there. Now we're going to square both sides. When I square both sides, I'm going to get D squared equals, and then I'm squaring the unsquare, so I'm just going to have 12 minus D. But now step 3, solving, is going to be a little bit more laborious because I've got a D squared and a D, and this is looking chapter 9-ish. It's looking quadratic-ish. I'm going to rewrite this with a plus D and a minus 12 equals 0. I'm just moving these to the left. And now what do I have to do to solve this? Thankfully, I can do magic numbers on this one. This is going to be 4 and 3, and this imaginary 1 is going to be 4 and 3, but it's going to be a positive 4 plus a negative 3 and a positive 4 times. So I've got D plus 4 times D minus 3 equals 0. And what do I do next? Oh yeah, I do either D plus 4 equals 0 or D minus 3 equals 0. Okay, so what are my solutions? D equals negative 4 or D equals positive 3. So I did step 1, step 2, I solved it, I got my solutions. Now what do I need to do? I need to check those solutions. And I need to do each one separately. So I'm going to check to see about negative 4. If I put a negative 4 here, I would get negative 4 equals the square root of 12 minus negative 4. Right? That was my original equation. So this is going to be 16. Does the square root of 16 equal negative 4? No. Interesting. What about when I check this one? I'm going to put a 3 here equals the square root of 12 minus 3. Well, that's 9. Does that one work? Yes. No. This is why it's important to check your solutions. Now, how come the negative 4 didn't work? Did we make a mistake? No, we did everything correctly. But when you're solving radical equations, sometimes your solutions are what we call extraneous solutions. An extraneous solution is you did everything right, you got your answers, but it still doesn't work when you plug it back in. It's a fake solution. And you don't want to fall for a fake solution. So don't tell me that d equals -4. D can't equal -4. The actual solution is only d equals 3. It's not that equations like this can't have two solutions, but you've got to check them, because sometimes you get fake solutions when you do this kind of problem solving. Sometimes you get extraneous solutions. So I'm going to make this say check for extraneous solutions. But if you're checking all your solutions, you'll catch that. Okay, so let's try one last problem. I'm going to try to solve this. The square root of x plus 5 equals x minus 1. Okay, step 1 was isolate the radical. It's already isolated. We're good to go. Step 2, square both sides. This is where the parentheses are really important. Okay, we know that this is going to be x plus 5. But if I don't write my parentheses here, and remember that I'm squaring the entire right side of this equation, I might just think that it's x squared and then 1 squared. But it's not. I'm squaring this whole side of the equation. And what does it mean to square x minus 1? It means to do x minus 1 times itself. Uh-oh, that means I've got a FOIL. That means I'm going to have a trinomial here. That means I'm going to have an x squared. What does this come out to? Minus 2x plus 1. And that means that if you just squared the x and just squared the 1, you're going to miss this part, and the rest of the problem is going to go haywire on you. So be careful. Now what do I have to do? I've got to solve this, and it's going to be quadratic-ish. So I've got to take away an x from both sides. That's going to give me a negative 3x. I've got to take away a 6 from both sides. 6. Why did I say 6? 5. Take away a 5 from both sides. That was weird. So 1 minus 5 is negative 4. This will come down. Now I've got the 0 that I always wanted my whole life. I've dreamed of having a 0 on the left side of the equation. And now I can use my quadratic problem solving skills. Are we going to be able to do magic numbers? Let's see. Negative 4 times 1. Negative 4 plus 1. So this is x minus 4. X plus 1. And my two solutions are going to be either x equals 4 or x equals negative 1. But I don't know. Those might be fake. Those might be extraneous. So I've got to plug them both in. So I'm going to test this one by putting a 4 here. And putting a 4 there. Does it work? The square root of 9 equals 3. Yes. This one works. Check this one. When I put a negative 1 in, negative 1 plus 5, and then square root that equals, put a negative 1 here. That's the square root of 4 equals negative 2. Sorry. That's an extraneous solution. And we need to cross it out and only keep the solution that actually is a real solution to this problem. So, it's not too difficult to solve radical equations. We're just going to isolate the radical, square both sides, solve, and then check to make sure we don't get fooled and tricked. And if we do all that, we'll be in good shape. And that's it for section 10.4. Your assignment is page 644. Numbers 9 through 20, 22 through 28, and then number 31 at the end. So, enjoy solving some radical equations, and I will talk to you again next time.